Good morning or good afternoon, wherever you are today. Thanks for being with us. We have a great webinar ahead today, and we're going to be talking about what happened in Share, what happened at Share, which was just a few weeks ago, some different trends and best practices, and what was on the mind of the people that attended. So today, you're going to hear from EJ and Tate. They are super smart guys who know their stuff, and I know you'll enjoy hanging out with them today. All right, what to know? Just to let you know that we're recording this webinar and we're going to send it in a link in a post-event email. And we're also going to have a live Q&A at the end. You can put your questions in at any time. You can use the Q&A tab or in the chat, and we will take those after we end the presentation. So I am going to now turn it over um, to our panelists and we'll get started.
Thanks, Beth.
Thank you, Beth. Um, Smart guys may be an overstatement but I'm gonna just let it ride because we are early in the presentation. Maybe they can decide. Tate, they can
There you
decide
go. I
at the
like that
end
idea.
if we're there. So in terms of our agenda, what we're gonna do is we're gonna just cover a few different topics. One of them is just kind of talk specifically about one of the strong themes that we heard at Share, which was making mainframe data more transparent. We're going to then talk a little bit further about some of the new regulations and so somehow how some of the existing regulations have been extended to include the mainframe and how the mainframe is now coming to the party and the requirements are there. We'll talk about some of the challenges that exist within that framework and just in general in terms of dealing with mainframe data as a part of your overall enterprise infrastructure. We'll talk about the obligatory mention of artificial intelligence and AI, because of course you can't do a webinar for any reason without saying AI, or else it gets disbarred. And then we'll have a short demo of the product that we offer, our ability to discover and protect information in applications on the mainframe, and then take some questions from you. So, Tate, I think that's all we covered. Is that
Yeah,
you
I
okay with
just,
that?
all of these items here are extremely relevant. I think every other session at Share had security or compliance in the title, and clearly for good reason, right? The mainframe isn't just still relevant, it's the beating heart of the global financial system. So I think that the bad actors know that, and that's why, if your CISO still thinks mainframe security means rack F and locked server rooms, this webinar is their wake-up call. So buckle up and let's take it away, EJ.
Okay, I will strap on my
Buckle up.
all of my, that's it. We'll be all set to go. So this slide kind of represents the big four themes that we heard at the show. And I think one of them is kind of Tate was talking about under this umbrella of transparency. So making, I think on the keynote speaker on the first day said that we have to make the data on the mainframe as transparent as it is for any other platform inside of the organization. And I think that resonates in a way, uh, certainly for practitioners, that the mainframe has always been kind of the mystery box, the black box that sat in the corner with the different people that didn't come to the same party as everybody else and didn't report their data the same way, or their infrastructure and the goods and the bads and the uglies. And this now is becoming part of the same party. So as we look at transparency, the four ways of kind of dealing with this information are: number one, through governance, and we'll talk a little bit more about governance as we go forward. The second piece of a strategy around ensuring that the data is transparent is through visibility, and we'll talk what visibility and discovery means on this platform. Once data is exposed, once we know what information exists, whether it is sensitive, proprietary, unique, or special for your environment, we want to be able to have protections that go in place. So we're going to talk a little bit about what protection looks like, and the real fundamental differences between persistent protection that IBM offers constantly and the PKware protections as we go forward within that. And then the last piece is that just talking about how the observability and continuous control relate to those topics. So to that end, let's kind of dig in deeper. Unless Tate, did I Did I cover
Yeah,
everything that you
yeah,
had wanted to
I
know?
think just what I mean, you're spot on. I think that what's really kind of changing in the industry, and you can see and hear it pretty much so everywhere in all the post-share conversations, right? For decades, we mainframers wore the nobody understands what we do kind of as this badge of honor. And it turns out that same mysticism also means that that includes your security teams, right? So, they couldn't see what was actually happening to the data. So it's like having the world's best vault, but not ever taking an inventory of actually what's inside of it, right? So I think that in general, the consensus is pretty clear. Transparency is not a threat to the mainframe reputation. It's the only way to preserve it. So if your data is invisible, it's also unprotectable. And that's what we're going to kind of rally around here today.
Next slide. So as we begin to dig into this topic, as Tate was talking about, this construct of visibility exists. The lens that we are putting on this, that the PKware folks are putting on this, is that PKware is a data first company. So the lens that we put on any conversation, whether it comes to protection, whether it comes to visibility or discovery, whether it comes to remediations, it is always about the data because we believe just fundamentally that the only reason that you are taking actions on the mainframe, the only reason that you're applying governance controls to the information that exists on this particular target or device is because there's insensitive and important data that exists on that device. So if you don't know what it is, then you can't really take action against it because you don't know if you're actually administering to the data that you have. So putting perimeter controls around it, ensuring that all data is encrypted on disk doesn't take into effect or take into the clause of data leaving an organization and putting stronger ACL controls and putting stronger identity controls on the data merely says, I know who's coming to the party, not what they're doing once they've come to the party. So, I've had Tate at my house and he's been a little unruly after he's come to the house. We can't keep track of that. We can only keep track of when he comes into the house. So for us, when we talk about this construct of data visibility, the first thing that we're talking about is that we have applications that exist on the mainframe that have been created for the last 25 or 30 years that nobody knows what these applications are really, what really is contained inside of those applications. They know what those applications do because they're focused on the result. We know that we have to run this to clear the credit cards that we had in an environment. We know we have to run this to make sure we updated all of our customer, hospital records or whatever, but we don't actually know how that work gets done. So having visibility to those application data sets that exist is one of the most primary and important things that we can do today to ensure that we are doing the right things in terms of hygiene and in terms of diligence and in terms of organizational controls. So data sets exist. We have to find a way to be able to deal with the discovery of that information, and then we have to be able to apply policies to it. One of the things that Tate is going to show you later on today is this construct of PKware um, uh, PKware's the PK Protector ZOS product, which allows us to actually look at applications that are built in COBOL that have written COBOL language that are grabbing data sets that are pulling data from DB2 or pulling data from GVG or pulling data from just native data sets that are sitting in VSAM in their environments and understanding what those applications look like, understanding what the key fields look like in that information and knowing what is true and what is false, if you will, within that set. So we want to provide the same level of organization to that data that we do to the rest of the enterprise, to our cloud data, to our databases that are sitting on disk. And so I think that the first piece of this story is finding it in the environment. And the mainframe is just part of the environment now today.
Yeah.
Take.
Yeah, yeah, it's exactly right. And just I mean, everybody knows this, but the mainframe has been accumulating data since before even some of our security analysts were even born, right? We're talking vSAM files, QSAM data sets, packed decimal data fields buried in COBOL copybooks that really haven't even been updated since the Reagan administration. So, it's like saying application data sets are the biggest challenge is really the understatement of the century. But the good news is that automated discovery technology has finally caught up to the complexity of our environments. You don't need to manually map 60 years of data anymore. That's not just a time saver; it's a career saver. So yeah, all the things that EJ's just talking about, absolute game changers for us, and finally providing that insight that into those application data sets that have been hidden and have been a mystery for over 6 decades.
I think you can change the slide, Beth. But I think the interesting point for me in terms of what Tate just talked about, and Tate and I have discussed this before, is that in many cases, all this data, this critical application data that you have been dealing with on your mainframes for the last 25 years is when you ask questions about what that data look it is and where it is and how it's being set up is like opening up the junk drawer in the kitchen. It's like pulling that drawer open and going, I know there's scissors in here. I'm sure that there is. I'm sure there's a battery. I can't find it. Where is the charging cable? I've got a charging cable that, but and you open up the drawer and you try to find things that are inside of that drawer, and you found a charging cable that's going to fit your BlackBerry. And that's, going to be helpful at some point, again, if we have a time machine. So what we're trying to do in terms of the environment is find ourselves control over this and finding a way of putting governance and governance over the data that we happen to have there and understanding what that information happens to be. So this slide is really representing one of the other themes that we heard at the show, which was that ultimately, the mainframe is providing the source of truth inside of your organization. It is the beginning of where the data starts. The data first was created and lived. This is the ground zero, if you will, of most of the information that has now flown through the organization. So your customer information uh, applications that exist has started on the mainframe and have now flown into these other systems that go farther down and further across the boundaries of your organization. And what happens if you are believing that the mainframe is your source of truth? The first thing you have to be able to do is have analytics against that data. Tell me what it is. Tell me when it was created. Tell me who owns it. Tell me the last time it was used. Tell me how it's being used to make sure that that information makes sense to it, and then be able to do reporting against it, right? So knowing what that data is and reporting against it allows you to at least have a statement to be able to get a chance to be able to be successful. The middle bullet on this slide is one that we're going to talk about a little bit later on, but the really good news about today, sitting in March of 2026, is that AI allows us to do a lot of the busy work that we were not able to do, that we had to throw humans at to turn order from chaos that we had within an organization or sift through data upon data before we can make sense of the information that we happen to have here. So making this a part of your story, making this a part of the team and not using it to, autofill your emails is the best source and the best use of your time. And so it demystifies that black box, if you will, that the mainframe was, and makes this really an active part of the overall enterprise data community.
Yeah, that's spot on. And I'm kind of jumping at up and down like this slide right here. Love it. You were just talking about EJ, how you're at the Gartner Data and Analytics Summit. You were just at Share the week before that, right? And so, even everybody's saying at the same time that AI is only as good as the data you feed it, right? And guess where that data lives? That's right, big iron. So I think, the mainframe is some legacy artifact that you need to route around on your way to the cloud, right? It's the governed source of truth. This is what EJ was talking about. If your data governance strategy does not include mainframe, you don't have a data governance strategy. It's just a bunch of wishful thinking, right? So you got to treat the mainframe as the crown jewels vault that it actually is, and not some like dusty attic that you're embarrassed to show to your guests. So, like I said, EJ is spot on with it. It's just as critical as well. We'll talk about some of this a little bit later on, but yeah, it's extremely critical to what everyone's doing today. So, excellent slide.
Beth? Yeah. So when we talk about applying that rigor, that governance rigor across the information that existing on this additional target that's inside of your organization. And the half step back that I would take to this conversation is one of the beauties of PKware in this land and in this particular issue, or the advent of this issue, is that PKware looks at the mainframe as just another target inside of your organization. So the mainframe exists like your cloud platforms exist, and there is no greater value if your data is in S3, or if it's in an Azure blob, or if it's sitting in Google Cloud. It could be sitting on your endpoints. It could be sitting on your file servers. It could be sitting anywhere within your organization. We don't care. We don't discriminate about where that data happens to be. And we can scan and discover and provide visibility to all of those platforms. And when it comes to things like regulation and compliance, that is important, because regulation doesn't say, show me all of your HIPAA data except in the cloud, or show me all of your HIPAA data, but it doesn't count if it's on your endpoint. And especially, don't talk to me about your PCI data except on the mainframe. We never put that excuse in place. We never had those pieces there. And so what's really important to us today when we talk about regulations? Well, DOJ's final rule came out, says that it requires classification and export controls for mainframe specific information. So you have to worry. It is explicit to say in April from April 25 and October of 25 to May of 26, you have to be able to have classification and export controls around mainframe data. So what does that mean? Means you got to know what it is. Got to have discovery on mainframe data, or you can't put classification in place. It doesn't make any sense. FISMA has done the same kind of things. We're doing full inclusion of IBM Z and other mainframes. All fall into the same FISMA scopes, the same baselines, the same monitoring controls. Those are all working off the same way. HIPAA security controls now have increased the way that you handle EPHI on the mainframe. How do we end up dealing with that stuff? We've got additional CJIS controls around security, and even NYDFS in terms of state laws have asked for better MFA controls, asked for other informations that happen to fall into place. So what's happened is that regulation has caught up to the mainframe, and the same rigor that that your organizations have put in place today around this information now has one more target that it needs to deal with. And you shouldn't have to do special things to deal with that data. You should do the same thing that you're doing everywhere else and be able to get a result out of that.
Yeah, yeah, you're right. The regulatory tsunami has officially made landfall on the mainframe. That is for sure. So yeah, let's think about this for a second. So HIPAA might mandate AS-256 encryption for all EPHI by mid 2026. You get FISMA goes to annual mandatory assessments in September. And then there's like what? CERCIA wants you to report breaches to CISA within 72 hours. And then, of course, you got the patchwork of state privacy laws that have to be navigated. But here's the thing, EJ. These regulations don't have a mainframe exemption, just like you were saying. There's no asterisk that says, unless your data is on the ZOS, in which case carry on. So I think that the days of the mainframe flying under the compliance radar are quite simply over. So yeah, absolutely spot on with that. It's here.
It's here and it's now.
It's
It's
here.
real. That's right. So Beth, I think what's interesting about this is that, you just kind of made reference to this a couple of times, Tate, in terms of the what that we have to do in terms of some of those pieces, talking especially around the handlings of HIPAA data and around the FISMA pieces of it. So we talk about protection, and protection is not a nice to have when it comes to regulation and governance, but it is a must have. Protection is a must have in terms of reducing the risk of data leaving your organization. And protection is also one of the mechanisms that we use to get through any kind of findings that we have within an organization. Data has done something else. We have to come back and take action against those pieces of it. So one of the fallbacks that have always existed on the mainframe, the binky to all data that existed in that platform, is persistent encryption, right? So IBM has done a wonderful job by allowing um, 256K encryption to exist on disk. So persistent encryption always exists, and it is encompassing to anything that happens on any disk that is written to the platform. We're able to kind of provide protection to it. So that's great. The problem, as those regulations begin to talk about, is that the expectation is the data doesn't just live on that platform, that the data is going to move. The data is going to move in transit, both from organization to organization in the mainframe and from one mainframe to another mainframe, but it is also going to be part of all of your modernization applications and techniques, which means the data is now going to move from this highly secure platform to these other platforms, which are more flexible or user leaning in terms of accessibility, but much heightened reduction in terms of security. So what happens then in that place if we are dealing with data that is now outside of the purview of the mainframe, and we don't know what that data is, and we don't know if it's sensitive or not? We have people that are handling the data that are probably making bad decisions. They're probably out there, one too many martinis at the end of the night. They're probably worrying through what else is happening with their data. So we have to be able to provide protections. And protection isn't just on disk, it is protection in terms of in flight. So, Tate, why don't you just talk a little bit about
Yeah.
some of the options that PKWare can provide for this?
Yeah. So just to reinforce a little bit about what you're saying is like, the I think the truth is that it's just now starting to really gain some steam. Like at PKWare, we've been talking about persistent data security well before 2004, right? And the reason why it even came up is because I remember the old trap I used to get into when I go to mainframe shows or talk to customers. They'd always try to challenge me back in the old PK zip days when, hey, why do I need to use zip when I can just compress the data to disk or to tape? Well, the problem with that is that that data is not transfer. You can't move that data off tape or off disk and expect it to be shared, especially still in a compressed state, right? So anyway, that's kind of like where our solution really started to take off. Same thing happens with IBM pervasive encryption, right? It's fantastic when the data is sitting on the disk. We understand the ZOS environment, mainframe, Z17s, hyper secure environments. That's great. But we know that data always leaves the building. It goes to the cloud. It goes to SaaS platforms. It gets extracted for analytics. It gets fed into AI models. It gets copied to dev test environments. And the moment that data crosses the ZOS boundary without any persistent protection, you've basically handed it a one-way ticket to the Wild West, right? And I think the difference is the mainframe community has finally and collectively internalized that secure on the mainframe does not mean secure everywhere. The two very different things. And even differently, they used to not care what happened after it left the mainframe. Yeah, we've done our job. Now they're part of the solution. So I think collectively the mindset is from an enterprise perspective, EJ, is I think it's all finally catching up. They've all come home to roost, and it's time to start actually actively working on this. So yeah, PKWare's got a fantastic solution that provides that persistent encryption. The security travels with the data wherever it goes, making PKWare's persistent encryption the last line of defense. If they steal your data, there's nothing they can do with it, right?
I think,
That's
yeah,
the key.
I'm sorry, I didn't mean to step into there.
That's right.
The point, I think I'm sorry, the result of the discussion that you're having right now is really what our next slide is all about. And it is the concept of, if you know that you need to protect the data and worry about that information, what you are doing is you are giving your CISOs and your data owners and your senior executives in an organization the opportunity to be able to make better decisions around their data because they know what it is. They can tell who's accessing that data. They can tell where that data is going, and they can have a policy under wraps that says, this is the way I am protecting it. So, Tate, you talked about motion. Motion is just part of a policy. And I was having a discussion here today or yesterday that was the concept was nobody says protect my PCI data only at rest. They say protect my PCI data, period. That's where it goes. They don't say protect my PCI data or my HIPAA data or my whatever data. Don't protect my sensitive data on all the platforms except this one. They don't have particular pieces. So we talked about this earlier. The mainframe is now part of the same policy that exists. The visibility of the data is now equal to it. So you can't encrypt unless you know what you're encrypting, or you can't feel good about encrypting unless you know what you're encrypting, because then you've left yourself a loss in terms of how those pieces and parts fit together. I think that the construct of observability falls under a couple of different kind of categories for us. One of them is taking this information and being able to put it under a pane of glass for you. So sending it off to your Splunk, sending it off to your control targets, your control surfaces that are giving you that single pane of glass that I can look at all the information. The mainframe data should just fit inside of that same continuous piece of information that goes back on. The second thing that I would talk about is that providing visibility or monitoring, it means not scanning data one time a year. It means consistently scanning your data. It means actively running tasks to be able to get something done or doing it dynamically, being after the data as it is created. Uh, I was having a conversation with a customer the other day, and I said, PKware doesn't paint portraits with your data. We paint bridges. We finish the scan, we turn around, we start again, and we do it again, and we do it again. And when we finish, we do it again because data is always changing. Data is always fresh. If you have latency between your scan and your actions, there's a potential for gaps, there's a potential for error, there's a potential for risk. So we want to be able to reduce that risk for our organizations by giving our CISOs and giving our executives the best chance to be successful. And that's all about observability. Don't say that twice, but you're muted, Tate.
Yeah, the trend at Share certainly has been that observability. Those are the standing room only sessions, and I think it's a pretty I think it's obvious why. I mean, the industry's finally waking up to their role in all this, and I think that mainframers have historically been great at answering is the system up, but really really bad at answering who just exported 50,000 customer records and emailed them to their Gmail account, right? So I think with Cercia wanting 72-hour breach notifications, you just can't afford to discover problems during your quarterly review, right? You need to know in real time, and it's like the difference between having a smoke detector and a fire insurance claim, right? It's just they're two totally different things for two totally different purposes. So I just think that it's here and now observability, being able to monitor that, and not getting caught during the actual audit that's where you want to be on that side of the audit, and that's what observability and continuous control can do for you.
I'm agreed. I think that the next arrow that you can put in your quiver, the next bullet you put in the gun in terms of providing the CISO and your executives better control is the concept of embracing AI. And AI was a heavy, heavy theme at Share this past year in terms of talking about how we can make sure we're utilizing it effectively, that it is a part of our uh, day-to-day processes, and that it's not just it's not a specialist where we're in basketball season. We're not talking about the three-point guy. We got to bring in somebody to the shooter that's just going to be available at the end of the third quarter or the fourth quarter. We have to use this all the time. And so one of the themes that we heard of these four themes that I'm just going to talk about quickly from the lessons that I learned is the first one is that this the technology has changed so much in the last 6 months from the 6 months before that, from the 6 months before that, that if your expectations about what AI is providing you is from 2023, then you are wildly outdated in terms of your expectations. So we are talking about um, the 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 latest versions of products from OpenAI and from Anthropic are providing us not the ability to hand a task off and then constantly monitor that task to make sure that it's being done correctly. We are handing tasks off to AI. Claude is turning around and writing code and saying, not only did I write the code, I tested the code and I'm going to give it back to you and say, did I do the thing that I was supposed to be able to do? So we are actually we should be thinking about AI as the smartest intern that you've ever hired at your organization who actually has a PhD, but doesn't understand the cultural mores of your organization. They don't understand where the data can go or can't go. They just do the thing that you've asked them to do. So what it's done is it's turned the requirement of the organization to be much more of the engineer in the software engineer than the software part. Writing the code is challenging and difficult and amazing, but AI can write the code. We have to engineer. If we are not creating good outcomes or focused on the workflow, we are not creating the right areas and the right expectations around our organization. So we should be thinking about it as a member of the team. We should be thinking about throwing as many tasks as we can and as many problems as we can and asking it to kind of look at the problem and come back and provide and giving us better results. I know that at PKware, AI is an active part of our development process, our QA process, and our innovation process. So in our innovation sprints, we are asking AI the the tough questions, if you will, that we have learned and saying, take a look at what we've done and how we've done it and put a fresh set of eyes on it that we respect because it has understood all the things that we have done from before. I think that it is really the disruption is that it is making us more efficient, more effective, and much more nimble. And I hate to use the word agile, but more agile in terms of what we're doing. So, Tate, you can probably
Yeah.
talk about this better than I can.
Yeah, well, I mean, so just to piggyback on a few things here. So yeah, the perception gap, and this is a quick one. It is real. It is interesting to watch leaders get their minds blown about what AI can do today because, they're still mentally benchmarking against early 2023 chat GPT. So it's like completely different experience. So yeah, if you're not actively using it and you're, well, it's got a place for everybody, I think, in the workspace. But like I said, if you're not using it in the engineering space as like your little co-processor or sidecar, you're just kind of getting behind. But no, nonetheless, but the legacy models point, EJ, is equally salient. I think too many shops are just like bolting AI onto the side of their architecture like a spoiler on a minivan. Don't judge. Instead of actually treating it really as a first class production workload that needs the same kind of rigor that like a CICS region would need. So yeah, like I said, it's real. But I think finally the skills mismatch really does hit close to home. We're training people to use AI tools, but not to think about AI systems. Yet data lineage, model governance, output validation, bias detection, my personal favorite, organizational antibodies. But in the end, I think that, AI on the mainframe just really isn't a technological challenge. It's a cultural challenge. But I think that really in this case, time waits for no one. So the transformation is going to be swift. We've seen crypto take like 20, 25 years to really catch on because, encrypting stuff scares people. But AI, it's just taken off. I've never quite seen anything equal to what AI is doing to the industry. So it's a fun ride.
Yeah, agreed. Spoiler on your minivan. I was thinking more of the Leonard Skinner mural that you had on the panel van that's also in your house, but that's a
Oh, nice.
different conversation
Yeah,
altogether.
yeah.
So I think that all of this leads to the next part of this conversation and the next part of the webinar, which is what is PKware providing that can help address the needs that we talked about at Share, the worrying about the trends and providing the tool set and the platform that is can best enable your organizations to be successful. And so what we're going to spend a little time talking about and you showing is is our PK Protect for ZOS product, which is a fundamental. The good news is that it is a changing product, or it changes the paradigm of providing what discovery means to the mainframe. We have an ability to understand the applications that you have created and that have been created in your organization. Traditionally, when we think about discovery, discovery falls into two buckets. It falls into this structured bucket, the DB2s, the IMSs, the SQLs, the Postgreses, the whatevers that you happen to have inside of your organization that have columns and rows that you need to be able to scan effectively, efficiently, quickly, and accurately to be able to get the results back that you happen to have. You have unstructured data that sits inside of your organization, files that sit, and we could be talking about Word files and text files and those kinds of files. We could be talking about Parquet files and Avro files and GDG files and VSEM files and files that exist anywhere, are specific to platforms, but exist anywhere inside of your organization. So what we want to be able to do is we want to look at those COBOL applications that you've existed. COBOL being the first of many application types that we're going to talk about, but just in the simple sense, COBOL is pervasive in these organizations. Everybody has COBOL applications. Everybody has been writing these forever. And so what do we need to be able to do? We need to be able to look at those applications. Application one has 4 fields. Application two has 10 fields. Application three has 400 fields. And we have to find a way to normalize what are those fields? What is the data that is underlying in those fields? Where does that data live? And how can we look at this in the same orderly fashion that we can look at structured and unstructured data? So what we have an ability to do is we have an ability to create logic from the chaos. And Tate, as much as I want to steal the thunder, I'm not going to steal it. I'm going to let you do it in terms of this. But the results of our effort means that we are reducing and eliminating the ability to do manual mapping of information, of having knowledge have to be stuck in somebody's head that they have to pour out so that in some document, you can understand where this data happens to be. We are going to create schemas. We're going to create order. We're going to create um, consistency and reusability in terms of this stuff so that we can go after the information and go after it again and go after it again. And once we've done that, we are going to be able to provide protections for you, both our protections, third-party protections, or third-party protections, but PKWare is at the ready to solve this problem in itself so that you don't have to go anywhere else outside of our ecosystem to solve the problem of finding and fixing. Tate, why don't you take it away?
Yeah, absolutely. So, yeah, basically, if you've ever tried to find sensitive data in like vSAM clusters or chase sensitive data through a chain of COBOL copybooks, JCL procs, undocumented batch jobs, it's like finding water in the desert. So the PK Protect approach using application source code, if you will, to identify sensitive elements, even in streams of uh, binary data, right? It's exactly what the mainframe's asking for. So I am going to steal the screen as soon as I find out where we are. Let's see if this is the one. You
Looks
guys
like
see
it
me?
is.
All right, fantastic. All right, so what you guys are looking at is our PK Protect platform. And as EJ alluded to, we basically, the overall user experience is the same regardless of which agent, environment, database, endpoint you're connected to, right? Overall workflow, experience, etc., is pretty darn similar. Naturally, some nuances here and there depending on where you're going, but generally speaking, it's all the same. So, in order for us to actually do any type of discovery, EJ was talking about a process we go through to generate these schemas that we use as the logic for the parsing and scanning for sensitive data. And I don't have to show you necessarily all that stuff, but I just kind of want to show you what a simple task might look like, right? So, and this is the same again for every single one of our agents. So basically, you're just going to put in a name for, and I'm going to just increase the size of this a little bit. You're going to create a name for this task. You got to create the task description. And the very first thing or the only thing that you can do before you've done any type of discovery is to detect, find something. All right. So, and then once you find it, you can start doing something about it. Right. So we need to find stuff first. And in this case, I'm going to tell it to look for the through the first 1,000 records, right? Assuming we know maybe something about our data, we think it's representative. So what I would do is I come over here to select data sets, and I can just pull down on the application name, right? So whether it's an application that generates a whole bunch of IBM pervasively encrypted data sets, and again, I just do it so you can see that we can read pervasively encrypted data sets, we can scan pervasively encrypted data sets, or like I said, any application that you want to scan, it's going to bring up data sets with schemas that allows you to pick and choose which data sets you want to scan, or you can just simply choose that you want to scan all of them. But nonetheless, I pick some data sets that I want to scan, and I add them to the overall task function. And once I'm satisfied, you see I've got some DA, KSDS, ESDS, VSAM, and some sequential data sets in there. I click on done. So again, I got my task, description, what it is I want to do, and then how much of it that I want to read, 1,000 records. And now I've got my data sets that I want to scan. In this case, they're associated with an application. Now I come down here and I say, all right, how do I want to treat whatever it is and what do I want to look for, right? So you come in here, we could pretend like you say, hey, I want to find PCI data, all right? And you see, it's called PCI Hadoop. Good news is I can share my policies with all the other agents out there. So whether it's an S3 bucket or a MongoDB database or some endpoint, I can reuse the exact same policy as long as it is relevant, right? It's got to make sense to you. But when I choose this one policy here, PCI Hadoop, you see over here on the right-hand side, it's choosing 3 out of a possible 130 predefined out-of-the-box sensitive types. Okay. As I select other policies, now I've got 2 policies. Now you see I've got 8 sensitive types out of 130. Well, that's good enough for our demo, but you get the idea. For every policy, there are a handful or a whole bunch of other sensitive types in there. And if I wanted to customize this a bit, I could continue to add on additional policies to those on top of add additional sensitive types to the existing policies and sensitive types that are already chosen over here. So anyway, but get back to our original selection, CCPA and PCI Hadoop policies that I'm going to run against those data sets, and let's see what happens. Now, not too much of a mystery as I've already done this, but I just at least wanted to show you guys that this is not a bunch of still screens, whatnot. This is actually running in the background, and I'm just going to go ahead. We are at the results screen. Let's just see what happens. So in this whole process, as we're scanning, we're actually pulling the schema from a runtime database for the data sets that we want to scan. We apply that schema over on top of that stream of binary data, and then we start scanning because we know everything about how your application writes that data. So right here, you see that we've got a couple of results, right? We see that we found sensitive data and these types of data sets over here. So when I go to my results, and this is kind of where this is the good stuff, I suppose. Over here on the left-hand side, you see that I'm looking for certain sensitive types, right? Those are the 8 sensitive types that we were individually looking for. Credit cards with dash separations, digits only, etc., right? Plus other sensitive types. So that's the sensitive type right there. Object type right here. We told it to look through the first 1,000 records. So that's what this column's telling us, is that it ran through those 1,000 records. We found 1,000 matches of what we were looking for. In this case, it gives us a confidence, which is kind of a score, makes you feel good somewhere. Get a confidence of 100, which is pretty darn good, right? So what did we find? Well, anybody that knows anything about mainframe data knows that CCNO dash field name. So these are all field names. None of that information exists in the data, right? This is what makes application discovery, sensitive data discovery, and application data sets. Nearly impossible to do unless you've got our solution. Not even conscious of anybody that's able to do this, right? So we are basically applying structured results to seemingly unstructured streams of binary data. And you could take this to the bank, right? So we got social security numbers down here too. Different types, different field names. Again, nowhere in that data, but we're getting massive hits on it. We're finding these field names. We're finding these field names that match. We got a field name match in this last column here. And if the field name matches, if I find an SSNO dash dash in that data or in the schema, if you will, I'm going to say yes. And that's going to bring my score, that confidence, up higher. If there is a mismatch, like in this example here, even though I got 908 out of 1,000, which if it matched, it would have been a confidence of 91. This time it only gave me a 76 because the field name didn't match what I already had in my regex. But guess what? All of this is auto-fed back into the scanning process. So like you want to add CCNs as a regex field that you want to be able to match to improve that confidence score. Easy enough. It's just a process of modifying the search and the results, looking at it, confirming that what you got is in fact what you're expecting. And here's a great example. I've got a field name called custom. Probably one of the worst field names you can come up with, but I've seen some pretty bad ones, right? Well, guess what? Only found 17 instances of what we were looking for, gave you a confidence of 1. Probably what you should get. But at the same time, you might want to go take a look and see what was in that custom field. Still make sure that it's still a legitimate part of your application. But that's what we're able to do, is kind of provide that insight. And one more thing, EJ, before I let you kind of carry this out for us, is that there's a couple of things. When we skip a file, one of the very first things we do before we do any type of detection is we do data validation. That means that if we're looking for a credit card field that is just digits only and it's not packed decimal data, that should be an integer field. But sometimes you get dirty data or non-conforming data, and it's sometimes just inadvertent mistakes in an application that has been updated, or something's just not writing the way that it's supposed to. But guess what? We were talking about AI, right? So until we tell you you've got dirty data, you're now ingesting that dirty data into your AI infrastructure. You're sharing with everybody for your analytics, etc. And it's wrong. And that's something that we will do before we even scan for sensitive data, is tell you if there's anything there that shouldn't be there from the get-go. That is one of the many powers of PK Protect. All right, EJ, I'm done. What do you want me to talk
I
about?
doubt, I doubt, I doubt you're done, to be honest with you, but we're going to do it. If you pop back over to the results for just 1 second, I just
Yeah.
want to bring home one other point that you said. So you talked about having those field names. And again, those field names exist because we scanned those applications, because we identified the various fields inside of the applications. We then placed them inside of a schema, and we allowed that information to go to be applied inside of our product set. So that data, if you just go back to there for 1 more second, that information doesn't exist in the wild. We didn't just read a column head. We generated it and we found it. So that obstacle exists for everybody that's trying to scan this kind of data, which is why it's so valuable to be with us. You spent time talking about confidence, and I think that the important piece of confidence that those of us listening on this call, but people inside of the organization, is that the curse of discovery is false positives and false negatives. That's the curse, right? You do a scan, you get a bunch of results, and you're like, oh man, I looked at those results. They weren't good. This actually was a credit card, or this actually wasn't, or whatever that falls under. What we're doing is that we're giving you our best guess at how this works. So when people talk about AI, washing our results and taking a look at things and giving you different kind of results. We're doing this already inside of our product that says through the rigor of the way that we identify data, organize data, and report data, we can tell you at a glance, yes, this was a real field. Yes, there's real data in there. And the 100% confidence stuff is super great to me. That's a wonderful part of the answer. I love the ones, Tate talked about custom. We think that this information exists in it. There are also probably fields inside of applications that are notes fields or comment fields, and we shouldn't find any hits. Those should be zeros. We shouldn't have anything that exists in there. If we get hits looking for emails or social security numbers or whatever it is, the sensitive elements that we're looking for. If we have any hits, that's also a notice to say something was put into this column that shouldn't have been there. You might have had a key operator that's taking in a credit card and puts it into that notes field or puts in a phone number that it shouldn't be. We're actually finding data that could be leaked. Tate talked about the skip data or the data that was ill-formed in terms of what we were dealing with. This is another area, is that you take a table and you throw it into AI to do analysis. If that comments field has sensitive data in it, you've leaked it outside of the organization unintentionally, but you've done it consciously. So we eliminate that opportunity for you to do that by simply showing you that information happens to exist. So the and the last thing about this interface that Tate is talking about, along that left-hand side, it says schema and it says ZOS datasets. Along that line in our product, this is where S3 would live. This is where Azure lives. This is where Google lives. This is where any database products live. The same interface, using the same policies, building the same tasks allows us to do it. So you are compressed in terms of the number of people that are on your team. The same person that can scan S3 can scan the mainframe, who can scan file servers, who can scan unstructured and structured data. You can share the same singular resource and cover multiple targets to get to the point that you need to be able to get to. So our purpose is to provide simplified organization and provide assurance that you get to do what you need to be able to do going forward. So I think, Beth, we are, of course, getting close to the end, and I want to make sure that we have time for any of the questions that exist. But are there any questions that we might be able to talk about? Beth
Yes.
is on mute too. There
Yes,
she goes.
yes, yes, we do have a couple of questions. The first one, I mean, we talked about encryption quite a bit, but this question is kind of like in layman's terms, what's the difference between traditional encryption and PK protect encryption?
So I'm going to just take one spin. I'll give you a shot on this one too. But I think that I had started to talk about this a little bit earlier in the presentation, but when people hear the word encryption, it scares people. And it scares people because, number one, when you've encrypted a file, if you don't have the passphrase or you don't have the key, then you can't access the data. You're basically creating ransomed data by encrypting it and not having access to the ability to decrypt it. So naturally speaking, encryption is kind of a scary concept. PKware has tried to reduce the risk, reduce the friction with that because we do a couple of things. Number one, um, we can apply this systemically, through the application sets. But more importantly, we provide what we call a contingency key to encryptions that happen within our organization. So persistent encryptions, the data-centric encryptions that we're talking about, we provide a secondary key that the organization can hold securely so that any data that has been encrypted, whether that data has encrypted in 1998 or last week, we have an ability to let the organization open that data, open up that payload, and ensure that there isn't anything that shouldn't be there or that you have access to that data and have visibility to it. So I think flexibility by the organization and the ability to have access to it through audit or through security is a great differentiator between us and just quote unquote standard encryption.
Yeah, so the carry on the the primary difference. So PKWare uses all standards, right? We didn't invent our own little algorithm and slap a label called AES 256 on it, right? So all NIST standards, FIPS standards that we use, and various forms of open PGP, et cetera. So all that stuff is standard, right? The primary difference between PKWare's implementation and everybody else's is that we leverage the portable and most ubiquitous zip file format, which is what PKWare was originally known for, because we have been leveraging persistent data-centric security since 1986, right? Now, sure, it was 96-bit encryption or 32 times 3, something that anybody with a Captain Midnight decoder ring could decrypt by today's standards, but nonetheless, it was part of what we did from day one, all right? Because we have been so successful with our zip file format, and I think nearly every single mainframe in the world has our product, plus every single AS400 or power system, and I mean it's everywhere, right? People have been transferring zip files back and forth for decades, and it's been buried in your batch jobs for equally as long. Well, guess what? We leverage that zip file format and basically build that security into it so that all you have to do if you want to build on top of your existing batch jobs and you want to layer on post quantum crypto AES 256, it's as simple as adding a parm to your existing batch jobs that have been running for 20 years, right? So, but we leverage the zip file format. The zip file format is getting appended even, right? To handle post quantum crypto, et cetera. So yeah, the zip file format is what makes us uniquely different. But at the same time, you don't want to use that. You don't have to zip it up, right? Again, it's all standard. So you can leverage it with zip or without. But like I said, most of our customers just want to integrate it into existing workflows. So yeah,
Perfect. Beth, I know we're almost running out of time. Is there
Yeah.
any more?
Just we can do one more question. It's an
Okay.
AI question. So,
Uh-oh. There we go.
you talked earlier about like how organizations were looking at it from a perspective of a few years ago. How should organizations actually be evaluating it now for 2026 and beyond?
Um, my short answer to this one is that I think that AI should just be a partner to your teams. It should be the next member of the team. So it is the member that helps you write code. It's the member that helps you debug applications. It's the member that helps you look at results and ensure that there's fidelity and integrity in that information. It's also the member that helps you plot out um, your plan and execute your plan and ensure that you're following on your timelines and that you've hit the mile markers that you're supposed to hit at. The the difference or the subtlety to me is that you have to provide oversight. And oversight isn't task oversight. Oversight is project oversight. It is understanding the workflow, understanding the outcome that you are trying to build to, and ensuring that you allow AI to become a part of the team to allow you to be as successful as you could possibly be.
yeah. Wow. So the mainframe, the Z17 is purpose built for AI inferencing. There's AI in every aspect of it. IBM has not just like invested in it, kind of. It's the future of the platform, right? And so this kind of goes back to my original statement that, you shouldn't be treating AI as just kind of like this side cool little feature. It should be a part of your infrastructure, right? Just like IBM has literally integrated it into nearly all aspects of the subsystems, the operating system, and even in the hardware, right? The firmware. So again, it's an absolute mission critical aspect of today's economy, right? We talk about it protecting the financial industry, the insurance, it's critical. So I think so while I think it's a team member, I think it's a little bit more than just that. I think it's how you think about doing business. And you see banks, etc., where fully taking advantage, and it's always the easy one is like fraud, right? Being able to find a simple credit card swipe in real time, being able to detect not just 10%, but every single transaction that comes through. That is today's reality. That is happening today. And that's with the Z17. And like I said, I think it's only going to continue to expand. It's going to be pervasive. It's going to be everywhere, and there's nothing you're going to be able to do about it. So, time to get on board and make it a part of your infrastructure.
I agree. We're set, Beth.
Well, we are at the end of the hour. We thank you all for joining us. Thank you, Tate and EJ. I think we all learned something. I learned something every time I chat with y'all. You're going to get an email from PK Ware with the recording, and we have a supplemental article on mainframe modernization that you should check out. So we hope everybody has a great day, and we'll see you next time.
Yeah, everyone, take
Thanks,
care.
folks.
Thanks.